Assalamu alaikum, dear students. Today our topic is chemical kinetics, in which we will study what is chemical kinetics, what is rate of reaction or the speed of reaction, what is average rate of reaction, and what is instantaneous rate of reaction. So first, what is chemical kinetics? We'll write its definition. It is the branch of chemistry which deals with study of speeds or rates of chemical reactions, factors affecting these rates, or rates of reactions, and mechanism by which the reactions proceed. So, what's chemical kinetics? It is that branch of chemistry which deals with the study of speeds, जिसमें हम रिएक्शनों की स्पीड या रेट ऑफ रिएक्शन स्टडी करते हैं, या जिसमें हम फैक्टर्स दैट इफेक्ट द रेट ऑफ द रिएक्शन स्टडी करते हैं, या द by which the mechanism by which the reactions proceed. तो ये सब कुछ chemical kinetics में आता है. Now, what is speed of the reaction? On the basis of speed, we can classify reactions number one, very fast reactions, number two, slow reactions, very slow reactions, number third, reactions which proceed with moderate speed. Now, very fast reactions are those reactions which take place instantaneously. And for example, we take the precipitate of the silver chloride. Silver chloride, its precipitate is formed instantaneously by mixing silver nitrate, aqueous solution of the silver nitrate, and sodium chloride. when the aqueous solution of silver nitrate and aqueous solution of sodium chloride are mixed, they form the precipitate AgCl plus NaNO3 is formed. This is a very fast reaction because instantaneously the precipitate of silver chloride is formed the moment we mix silver nitrate and sodium chloride aqueous solutions. And the time period for such reaction is almost 10 raised power minus 12 to 10 raised power minus 16 seconds. Or we can have NaCl, HCl, hydrochloric acid aqueous plus NaOH aqueous solution forms NaCl aqueous plus water. This too is a very fast reaction. So we have very slow reaction. For example, the rusting of iron. We will take the very slow reaction as the rusting of iron. In presence of air and moisture, it is a very slow reaction. It takes days, months or years together to get completed. Reactions in which proceed at moderate speed. There are reactions which proceed with the moderate speed, like the decomposition of hydrogen peroxide. Decomposition of H2O2 or hydrolysis of cane sugar. So the decomposition of hydrogen peroxide, it forms H2O plus O2 1/2 or C12H22O11. The hydrolysis of the cane sugar, when we add water to it, it forms C6H12O6 plus C6H12O6. This is glucose and fructose. These reactions proceed with a moderate speed. What I mean to say is that we have reactions which proceed with different speeds. So, just like the speed of the automobile is determined, the speed of the automobile is determined by dividing the distance traveled in a certain time period. Distance traveled in certain time period gives us the speed of the automobiles. Similarly, we can determine the rate of the chemical reaction or the speed of the chemical reaction just like we determine the speed of these automobiles. Now, what is the rate of the chemical reaction? We will first define a rate of a chemical reaction. It is the measurement of speed. with which the reactants are converted into products. It is defined as the decrease in the concentration of it is defined as the change in the concentration of reactants, concentration of any one of the reactants or products per unit time. Or we can write the rate of reaction is equal to decrease in the concentration of reactant divided by time period, or it is also equal to increase in the concentration of product divided by time period. Now I will again explain it. The rate of reaction, which is actually the speed of the reaction, we define it as the change in the concentration of any one of the reactants, or we can say the decrease in the concentration of the reactant, or the concentration of the product, that is increase in the concentration of the product per unit time divided by time period. Now I will explain it by taking a hypothetical reaction. Let's take a hypothetical reaction. What is that reaction? Suppose R gives P. The reactant gives product. 1 mole of the reactant gives 1 mole of the product. Now, in order to determine the rate of this reaction, let R1 and P1 be the concentration of reactant and product at T1. So at T1 the concentration of the reactant is R1 and the concentration of the product is P1, and let R2 and P2 be the concentration of the reactant and product at time T2. But here we must remember that as the reaction proceeds, the concentration of the reactant go on decreasing and the concentration of the product go on increasing, because R gets consumed and P product is formed. So the value of the concentration of the reactant, that is R2 at T2, is smaller than the value of the concentration of the reactant at time T1. That means R2 has a smaller value than R1 because more and more of the reactant gets consumed into the product. Similarly, the concentration of the product at time T2, that is P2, is higher, is greater than that of the concentration of P1 because with the passage of the time the product is formed, so P2 has higher value than P1. Now what is the change in the concentration? Now del R is equal to R2 minus R1. This is the change in the concentration of the reactant is R2 minus R1, and del P is equal to P2 minus P1, and del T is equal to T2 minus T1. Now we will write the rate of the reaction. The rate of the reaction will be it is the change in the concentration, it is decrease in the concentration of the reactant, that is del R by del T. But remember, this you have to remember that the change in the concentration of the reactant is a negative quantity because R2 is smaller than R1. So this is a negative quantity. When we divide the negative quantity by del T, the time we again get a negative quantity, but the rate of reaction can never be negative. So we multiply it by -1, that is minus, so that the value of the rate of reaction will be positive, and it is also equal to del P divided by del T. Now del P is P2 minus P1, and the concentration of the product at T2 is higher than P1, so it is always a positive quantity. So this is the rate of the reaction, that is minus del R divided by del T, or it is plus del P divided by del T. The negative and the positive sign indicate, the negative sign indicates the decrease in the concentration of the reactant, and the positive sign here shows the increase in the concentration of the product. So whenever we have to write the rate of reaction, we can write it in terms of the concentration of the reactant as well as in the concentration of the product. लेकिन जब हम concentration of the in terms of the concentration of the reactant, there we have to keep the minus sign with it because the overall rate of reaction will then be a positive quantity because the concentration of the reactant decreases with the passage of the time. Now, if we will take general reaction and we have to write the rate of reaction for that general reaction, how we can write it? Suppose we have a general reaction, A plus B gives C plus D, and we have to write the rate of reaction for this reaction. The rate of reaction will be it is del A divided by del T is equal to del B divided by del T is equal to del C divided by del T is equal to del D divided by del T. Here again we must remember that the square bracket is used to represent, to express the molar concentration, and for the large change we denote del, and for smaller changes we denote it by small d. Now the rate of reaction cannot only be this, because here when we take the reactant we have to put the minus sign, because the concentration of the reactant decreases, and we have to put the positive sign here because the concentration of the product increases. So again, if we have the reaction like Hi gives H2 plus I2 twice, Hi gives H2 plus hydrogen iodide, decompose and forms hydrogen and iodine. For the reactions in which the stoichiometric coefficients, here these are called, here the stoichiometric coefficient of A is 1, it is also 1, it is also 1, it is 1. In case of the reactions where the stoichiometric coefficients are not equal to 1, and for expressing the rate of those reactions, the rate of, this is the rate of decrease, the rate of decomposition of the Hi, or rate of formation of any one of the rate of decomposition of any one of the reactant, or rate of formation of any one of the product is divided by their stoichiometric ratios, so that their rate will be equal. And for expressing the rate of such reactions we can express their rate like this, यानी कि वो रिएक्शन जिनका स्टिशोमेट्रिक कोएफिशिएंट सेम न हो, 1 के बराबर न हो, उनके रेट ऑफ डिकम्पोजिशन और रेट ऑफ फॉर्मेशन को हम उसके स्टिशोमेट्रिक रेशियो से डिवाइड करते हैं while writing the rate of reaction. So it will be equal to del Hi. Now it is the reactant and we multiply it by minus, divide by 2 into del T. This will be the rate of the reaction when we take the reactant, or when we take the product it will be del H2 positive divided by del T is equal to del I2 divided by del T. This is also positive, this is positive. Now, after completing the rate of reaction, we will write the units of the rate of reaction. Units of rate of reaction. As the rate of reaction is the decrease in the concentration divided by time period. So concentration, the unit of the concentration is moles per liter. It is change in concentration divided by time period. So this is the change in the concentration divided by time period is equal to the rate of reaction. So we will write the unit of change in concentration. The concentration means moles per liter and the time is second. So we write moles liter inverse second inverse, or this is mole per liter per second, the unit of rate of reaction. And if the time is in minutes, then we can write mole per liter per minute. And if we have gaseous reactions, in the gaseous reactions we use pressure instead of molar concentration, and the unit of pressure is atmosphere. So instead of moles per liter, it is atmosphere per second. In case of the reactions, this is the unit of the rate of reaction in case of the gaseous reactions. Now, what is average rate of reaction? Average rate of reaction. And how we can calculate the average rate of reaction? According to the law of mass action, the rate of reaction depends upon the concentration of the reactants, which keep on decreasing with the passage of the time. As the time passes, the concentration of the reactant decreases, but the rate of reaction depends upon the concentration of the reactant. That means we can say that the rate of the reaction does not remain constant throughout. The rate of the reaction does not remain constant throughout. Or we can define the rate of reaction. It is defined as the rate of change of concentration of any one of the reactant or product in a given time. एक गिवन टाइम पे जब हम रेट ऑफ रिएक्शन किसी रिएक्शन का निकालेंगे, दैट विल गिव अस द एवरेज रेट ऑफ रिएक्शन. So the average rate of reaction is actually the rate of reaction that which we have defined, but we will calculate it in a given time period. Now how we can calculate the average rate of reaction? Calculation of average rate of reaction. In order to calculate the average rate of reaction between a given time period, say T1 and T2, we will draw a graph between the change in the concentration values of any one of the reactant or the product versus time. So we will draw the graph like this. It is for both. By one way, by taking the concentration of the reactant, the plot of the concentration of the reactant and the time period, we can determine the average rate of reaction. Or if we take the product, the concentration of the any one of the product, and plot it with the time. We can also determine the average rate of reaction. Here we will take both the reactant and the product, and we'll see how we can determine the average rate of reaction. This is the concentration of reactant in moles per liter. And this is time. We will take time in minutes. Five minute, 10 minute, 15, 20, 25. We'll take the molar concentration. Suppose this is 0.01, 0.02, 0.03, 0.04, 0.05. This is the concentration of the reactant, that is moles per liter, which change with the passage of the time as the reaction proceeds. Now this is reactant. When the time is 0, what is the concentration of the reactant? The concentration of the reactant has a maximum value. Suppose that is 0.05. Now, as the reaction passes on, the concentration of the reactant go on decreasing because now the product is formed. The reactant disappears and the product appears. So the concentration of the reactant decreases with the passage of the time, and we have the graph like this. And now we have to calculate the average rate of reaction between a given time period. Let our given time period be T1 and T2, and we will calculate the molar concentration. We will first note the molar concentration of the reactant at this time T1 and T2, then we will calculate the rate of reaction. Let our T1 be this, and our T2 be this. So this is T1 and T2. Between T1 and T2 time, we have to calculate the average rate of reaction. And we will note the concentrations of the reactant at time T1. It is like this. Suppose at T1 it is X1, and at T2 it is X2. But keep in mind that as the reaction passes on, the concentration of the reactant decreases, therefore the X2 is smaller than X1. So we can write the rate of reaction as it is average rate of reaction, because we are calculating the rate in a specific time period in a limited time. That is X2 minus X1 divided by T2 minus T1. X2 minus X1, because X2 is the concentration at T2. Now it has a smaller value than X1, so we keep minus sign here. Or this is equal to X1 minus X2 by multiplying with negative sign. So it will T2 minus T1. It will be equal to, if we will substitute the values from the plot, X1 has higher value than X2, that is 0.2 or 0.3 ये दरमियान में है. It is almost 0.26 या 0.27, 0.027. minus, it is 0.01, 0.01, and T2 is 15 minus 5, that is 10. 15 minus 5. So we will subtract it. It is 0.710 divided by 10. When we divide it, 0.0017 mole per liter per minute will give us the average rate of reaction. Now, if we take now the product, and how we can determine the average rate of reaction by taking the product. When we take the product, and plot the different values of the product, concentration of the product with the time, again we will take time in minute. We will not mention the time here, simply we will write the values. This is 0 and the time increases, and this is concentration of product. It is moles per liter, and the values increase from below to above. Now, when we take the product and plot its concentration values with the time, when t is equal to 0, what is the value of the product? Product is not formed, and as the time passes, the product is formed. More and more product is formed. So the plot of the product will be like this. Here the concentration of the reactant was maximum and it decreases. Here the product is 0 and it is value, the concentration increases with the passage of the time, because with the passage of the time the product is formed. So we will now calculate the average rate of reaction between the time period, say T1 and T2. Now at T1, we will note the concentration of the product. At T1, it will be equal to X1. And at T2, its value will be equal to X2. This is X2 and this is X1. From the graph it is clear that when we are taking the product, X2 is greater than X1 because the values increase as we move upwards. So the average rate of reaction will be X2 minus X1 divided by T2 minus T1, because here the X2 has greater value than X1, so we will keep the positive value here. This is, we have not mentioned the values, so X2 minus X1, when we substitute the value of X2, when we substitute the value of X1, T1 and T2, we will determine the rate, average rate of reaction by taking the product. Similarly, if we will now take the instantaneous rate of reaction, so that will do in the next lecture we will do. Today it is sufficient.